Here are things that lots of people forget from their introductory programming course in Java. First, declare variables before using them. Variable declaration is a type, then a name. This increases a numeric variable by 1. It's known as a post increment. So does this. This is a pre-increment. And so does this. However, you can change this number to change the amount you increase by. This example adds 5. You can also replace the operator before the equal sign with another arithmetic operator, like multiply, divide, or subtract. The subtract can also be used to decrement by 1. And you can do pre- and post-decrements, like this and this. Integer division always rounds down. Variables are only visible inside of the curly braces they are defined inside of. This is known as scope. This is a method header, also known as a method signature. This part in parentheses contains formal parameters. Formal parameters have a type, then a name, just like other variables. Formal parameters are also in the scope of the curly braces that follow the header. This is a method call. These are known as actual parameters. Method calls do not specify the types of the parameters the way they are specified in method headers. Actual parameters don't even have to be variables. They can be literals or expressions. Methods with return types must return a value of that type. Nothing can happen after a return statement. However, conditional statements like these if and else if blocks can create different execution pathways through the code. Code in an if block only executes if this test is true. Code in the else only executes if that preceding test is not true. Code in an else if only executes if the first test is not true and the second test is true. You can have several else if statements in a row, which incidentally is equivalent to this, though the first option is prettier. In a method with a return value, every possible pathway has to lead to a return statement. It's best if the whole method has one common exit point. When you call a method with a return value, you usually want to do something with that value. You can set a variable equal to the result, or you can perform the method call anywhere that a result of that type is expected. You can even nest calls, and so on. A for loop has an initialization, test, and update. The initialization executes once before the for loop. The test is checked before each iteration. The update executes at the end of each iteration. Each part of the for loop is optional. For loops and while loops are only stylistically different. You can turn a for loop into a while loop like this. An array is declared with square brackets following the type. An array is a type like any other and can appear wherever types appear. Here is how you create a new empty array with a certain capacity. This is how you get the number of elements an array can hold, with the length property. This is how you access and change one value in the array, with the index and square brackets. This can also be a variable or expression that evaluates to an integer. If the value is negative or greater than or equal to the length, you'll get an array index out of bounds exception. This is a 2D array. You specify each index individually. Arrays are reference types. If you pass them to a method and change them, then the original array is modified, not a copy. Objects are reference types too. Object types are constructed using the new keyword along with some parameters. These are going to be defined in one of the object's constructors. Once you construct an object, you can call its non-static methods. You have object, then dot, then the method, and then parameters. A constructor typically initializes global private member variables, like these. These are also known as fields. Each instance of an object has their own copies of these instance variables, so different object instances can have different values. If the object variable is null, you'll get a null pointer exception whenever you try to call one of its methods. The default way an object is displayed is as a name and memory address. But you can change this by defining a toString method for the object. If you compare objects with equals equals, you are only checking if they refer to the exact same object. However, some objects might represent the same data even though they are different objects in memory. Compare them using the dot equals method. Do not use dot equals if the object is null, since it will cause an exception. Use equals equals in this case. Also use equals equals for comparing primitive types, integers, longs, doubles, floats, chars, etc. A few object types are weird and might work with equals equals sometimes, but not others, like string and integer. Just use dot equals to be safe. If you want to call a static method of a class from another class, then use the class name, then dot, then the method name, and then parameters. Now, I know I left out a lot. I didn't talk about array lists, Boolean operators, scanners, the comparable interface, and probably more. But this video is getting pretty long, so we'll catch up on the rest later. Bye for now.